So you've got an extra GPU laying around, and you want to use that on your Linux server. But your Linux server is virtualized and headless, and you'd like to take advantage of that GPU using Docker or some of your Kubernetes workloads. Well, if you'd like to take advantage of that GPU for some of your Kubernetes workloads, for things like TensorFlow, machine learning, deep learning, or maybe even Plex, well, get out your buzzword bingo card because I think we just got a bingo. Hey, welcome back. So I'm Techno Tim, and today we're going to talk about using your NVIDIA GPU for Docker and Kubernetes workloads. As a quick reminder, I stream every Tuesday, Thursday, and Saturday, so if you want to continue the conversation about passing through an NVIDIA GPU to an Ubuntu server there, that was a mouthful. We can. So let's talk about using your NVIDIA video card for a Kubernetes workload. So why would you want to use your video card in Kubernetes or Docker? Well, you might have a Docker container that can take advantage of that video card. There are plenty of containers out there that can use your GPU for things like deep learning, AI, or something as simple as Plex. These containers can offload that processing to the GPU, which frees up your CPU to do other tasks. And not only that, some workloads like AI, deep learning, and data science are optimized for GPU accelerated computing. But then you also have some workloads that just want to use the encoder, things like Plex or Jellyfin. And that's where the challenge comes in. Getting Docker containers to play well with NVIDIA's Docker container can be a challenge. And if you're virtualizing that Linux machine, it can also be a challenge to pass that GPU through from the host to the guest. Now, I've already done this a few times, and so I think I have the process down. So that's what we're going to talk about today. So today, in this video, we're going to use an NVIDIA GPU within a Linux virtual machine. We'll then use that GPU within Docker and Kubernetes. We'll install a few other tools to monitor and measure our GPU. Then we'll run a deep learning container to check our work. Then after that's working, we'll apply this to something a little more practical for me, which is Plex transcoding in Docker and Kubernetes. We'll use the same tools to monitor and measure that transcoding, and then permanently offload all of our transcoding to the GPU. Did you get a buzzword bingo yet? So with that out of the way, let's get started. The first thing you're going to need is a GPU. I've had success with some consumer grade cards like an NVIDIA 1050 or a 1650, but Quadros will also work. Once you have that video card, you'll want to install it in your server. You'll want to make sure that your server and processor support IOMMU, and that's so we can pass through this video card to our virtual machine. And if you need help with that on Proxmox, I've got a guide on how to pass through your GPU to a virtual machine. You'll follow that same process, but then create a Linux virtual machine at the end. Then you'll want to be sure that you enable IOMMU. Then after that, create your Linux virtual machine and shut it down. Now, if you're doing this on a bare metal Linux server, you don't have to do this. But if you have virtualized it, we'll need to change a couple of things. In the hardware tab, we'll add our PCI device. In the device dropdown, you should see your NVIDIA GPU, and then we'll add the device. Then you'll want to SSH into your Proxmox server. There, we'll edit one thing on our virtual machines config. Be sure to pick the right virtual machine, and this is indicated by the ID. Here, we'll want to add a couple flags to our CPU. I've added host hidden equals 1 and flags equal plus PCID. Once you have that set, you can start your virtual machine back up. Then you'll want to SSH into that virtual machine and run this command. The command is lshw-c video. And when you run that command, we should see our NVIDIA video card there. So this is a good sign. Now we need to install the NVIDIA drivers. This part is kind of tricky. Because we're running a headless server, we don't want to install any of the X11 stuff, because there's no point in installing a windowing system when it's headless. So here's the command you use. First, you'll want to update aptitude. Then we'll want to run this command right here. So this command is for the latest NVIDIA drivers, which at this point it's 450. But we'll want to be sure we don't install any recommended packages. So we'll need the NVIDIA CUDA toolkit, the NVIDIA headless driver for 450, the NVIDIA utils for 450, and then libvidia-encode 450. Now this last one, the encode piece, took a while for me to figure out, but this is really important if you're going to do Plex transcoding. So let's install these. Say yes. Then you want to reboot your server. Now that the driver is installed, we need to install some additional configuration for Docker. First, we'll set our distribution. Then we'll add a GPG key. Then we'll add an app source. Then we'll add the NVIDIA container toolkit. Then we'll install the NVIDIA container runtime. I've also needed to install this package. It's nvidia-docker 2. And when prompted, I typically say no here. And that prompt was to update our daemon.json file. And so we need to create a new one so that our Docker and Kubernetes can take advantage of the NVIDIA runtime. So let's do that. So let's modify that file and let's replace it with this JSON. And don't worry, all of these commands as well as this JSON will be in the documentation, and you can find that in the description. So we'll save this. Now we'll need to restart the Docker process. Now, after all that, we can test our driver. So let's query our video card first from the guest machine. And that's as simple as running nvidia-smi. This should respond with your video card. So this is a good sign. This means that our video card is exposed to our virtual machine. But now we actually want to check to make sure it's exposed to Docker. And so we'll run a similar command, but within a Docker container. And that's docker run --rm -gpus all nvidia CUDA 11 base, and then we'll run that command, nvidia-smi. And so this will pull down the Docker image, spin up a container, and run that command. And as we can see here, we were able to execute that command within the Docker container. And that Docker container can communicate with the virtual machine, which exposes the driver. So this is a good sign. This means that Docker can also communicate with our video card. Next, we'll install a tool called nvtop. So this is a nice tool that helps you visualize your NVIDIA GPU. And we'll use this to make sure that our processes are taking advantage of our video card. So let's install nvtop. And if we run nvtop, we can see it can query our video card. And as you can see, nothing really is going on. And so on the right side, I'm going to open another session to this server so that I can launch a deep learning workload. And this is a TensorFlow workload. The nice part about this is you don't have to install all the dependencies to run a TensorFlow workload now. You can just spin up a Docker container. So let's do that. So you can see on the right, it's pulling down this TensorFlow workload. This is a workload that should take advantage of our GPU. And now let's run this AI training script. And once we run the script, we can see on the left side that nvtop is reporting we have a process. And this process is being used from Docker. And you can see right away that the RAM shoots up. And so this is a really good sign. So far, we've passed the GPU through to our Linux guest. From there, we were able to install the NVIDIA drivers. And then from there, we've exposed our NVIDIA GPU to Docker. And now we're able to spin up TensorFlow really easily in a Docker container and take advantage of that video card. And if we wait long enough for this training, we should see the GPU start to spike. But we can exercise that GPU using Plex. In a previous video, I helped you fully set up Plex using Kubernetes, Rancher, and Docker. In that video, we walked through setting up Plex using Rancher. And if you set it up using my guide, we'll need to tweak a few things before we can take advantage of this video card. The first thing we'll need to do is install the NVIDIA device plugin. This allows us to use our NVIDIA device in Kubernetes. And it's real easy to do. So in Rancher, we'll want to go to our cluster, and then we'll want to launch kube control. We'll apply the NVIDIA device plugin here. And after that, you can verify it by going to cluster, system, and you should see the NVIDIA device plugin listed here. Okay, this means now that our Kubernetes workloads can now take advantage of this video card. And so let's get back to our Plex installation. There's one thing we need to change. So if we go into our Plex workload and we edit this workload, we'll need to add one environment variable, and that's NVIDIA visible devices, and we'll give it the value of all. This will allow our Plex container to query our NVIDIA devices and use them. If you have problems using all, you can query your device using this command. This command will query the device and give you back your UUID, and you can plug that UUID in the value instead of all. This is the value I would use here instead of all if I were having problems. But if all works, just use all. Okay, let's save this workload. Now, once we save that, we should be able to use our NVIDIA video card within a Plex Docker container. And once you're in the Plex settings, you want to make a few changes. In the Transcoder section, you'll want to make sure that Use Hardware Acceleration when available is turned on. Then we want to show Advanced. Here, we'll also want to make sure that we turn on Use Hardware Accelerated Video Encoding. This will use our GPU when we're transcoding. Also worth mentioning that this is a Plex Pass feature. Okay, make sure that you save that, and now let's transcode some video. So you can see on the left I have nvtop open. This is nvtop running inside of my Linux server. And on the right I have a 4K video. And let's click play. And so you can see right away that we're able to use this video card. On the left, you can see my GPU is using around 6 or 7% of this. And this is transcoding a 4K file. You can see it's using about a half a gig of memory, which is to be expected. And you can see that my CPU usage is pretty low. Here, I'm only using 35% of my CPU. Typically, when I transcode stuff, this goes anywhere from 100 to 800 depending on how many cores you have. So let's really turn it up. And you can see here I have quite a few streams running now. And you can see here my GPU is keeping up. The other cool thing is if we go into our Plex dashboard and look at these streams, we can see that these are being hardware transcoded, which this is a good sign. It means it's using our GPU. And this is just one more example of what you can do with the GPU you have laying around. The cool part about this is because it's running in Docker, we can have multiple Docker processes taking advantage of this GPU. So if you have Plex, Jellyfin, MB, or any other Docker container that can use your GPU, you can now give them all access to your GPU. And so I hope this shows you how awesome this is to be able to take advantage of your GPU, not only on the virtual machine, but within a Docker container. This opens up a ton of possibilities. If you have multiple Docker containers or Kubernetes workloads that can take advantage of your GPU, you can do this all within one virtual machine. And then you don't need multiple virtual machines with multiple video cards. But if you plan on running more workloads than just a couple, I recommend investing in some Quadro cards. Those will perform a little bit better under these types of loads. But for me and the workloads I run, I'm going to stick to a consumer card. So, what do you think about running workloads that can take advantage of an NVIDIA GPU? What do you think about applying this to AI, machine learning, or data science? Did you get a bingo in our buzzword bingo game? If so, let me know in the comments section below. And while you're in the comments, don't forget to give this video a thumbs up and consider subscribing if you haven't already. And if you have more questions, you can always join my live stream. I stream every Tuesday, Thursday, and Saturday, so if you have a question about this video or any of my other videos, hop into my stream and I'd love to have you. So, thanks so much for watching, and till next time, stream on, my friends.
Version controlled. And so the cool thing about that is that, Kube control. Sorry, I had to say Kube cuddle. Hey, Kube CTL. Should we call you Kube CTL? Kube cuddle, Kube control, or Cube control, or Cube cuddle. Hey, thanks for the follow. Appreciate it. Welcome. So anyways,